Okay, part B. Awena takes a random sample of size 11 from her dataset and plots the following scatter diagram. Using the computer output above, which means the value of this that we've got printed here, carry out a one-tailed significance test on the sample product moment correlation coefficient at the 0.5 level. So this is the hypothesis test for our PMCC value. Okay, so we start off with H0 and H1. Now you can put that in words or you can put it in symbols. If you're going to put in symbols, you want to use the symbol rho, which looks a bit like a P, but it's the Greek letter R. And you're saying that there is no correlation between your forearm and your bicep in H0. And for H1, remember we were looking for any positive correlation. We've already established in the part A of this question that it's a one-tailed test. So we're looking for rho to be greater than 0, or if you want to put it in words, you say positive correlation between. Okay, so that's the start. We've got a value of r squared. Now our test statistic from our data is the value of r. So here they've been a little bit cheeky because they've given r squared, and we need first of all to spot that we need to square root 0.9412, and actually as you square root you get 0.97015. If you miss that step, you'll probably still get the right conclusion, but obviously you'll lose the mark for not spotting that. And then in another question, it might make the conclusion go wrong as well. Okay, so my test statistic is the value of r. My critical value that I need next, you look up from your stats table. Now you'll have that in the exam. Okay, if you don't have a copy at home, you can find it easily online. You're looking for table 9, the critical values of the product moment correlation coefficient. You get a table of data. You have to make sure you're reading off the right column. So you're looking at the column on the far right here, which is one tail 0.5%. It's the fifth out of the 5 columns. Okay, you go down as far as n is 11 and you write down 0.7348. That's your critical value. Okay, all we need to do is make a comparison of our test statistic and our critical value. If you like, you can do the whole correlation from -1 across to 1. Where the critical value is, from that critical value out to the side, okay, whichever side it's on, is going to give you what we call the critical region. If you were testing a negative R value, you would need to use a negative sign in front of the critical value, and then your critical region would be down here where my pen's showing you now. But we've got a positive R value and a positive critical value therefore. So our test statistic falls easily into the critical region. Okay, it's very high. The basic idea with this is that you're saying, is your correlation value big enough? And here the answer is yes, it's definitely big enough to show that we've got correlation. It has to be bigger than 0.7348 in this situation. So our test statistic is in the critical region. Therefore, we can reject H0. So if it falls into the critical region, you can reject H0. That means you can stop believing that there's no correlation and change your mind and say that there, on this evidence, it looks like there is positive correlation. Okay, so we can conclude that there is evidence of positive correlation between forearm and bicep girth. You always need to say what you are doing in terms of the hypotheses. Are you rejecting H0 or are you not rejecting H0? And then you also always need to say a sentence, putting it into words and putting it into context. Okay, so we're saying it looks like there is evidence of positive correlation between forearm and bicep girth on this sample. Okay, we've got a sample of 11. Now it might be that a different sample wouldn't show positive correlation, wouldn't show any correlation at all. So you don't ever say anything so definite. You just say it looks like there's evidence on this sample.